Today I'd like to talk a little bit more about SPDX's SBOMs and what we're doing in the project to enable the automation of the safety and security analysis. Software is used in critical infrastructure systems today. That's sort of a given. And there is certain considerations now when we're using software in this place, because a lot of the software right now is mixed criticality. It's either mixed criticality and it's also open and proprietary. We're seeing all of these combinations showing up in these spaces. Various surveys happen in the industry, and about 70% of the code bases 70% of the code bases had OSS on average. 98 had some. We're having to work with a lot of different systems and software coming from a variety of places, and as a result, we kind of need to know what's going on there, especially in the security space. One of the interesting reports that came out last year was from the Japanese NISC organization, where they were basically making a point of focusing that we have to, as we're improving our, working with critical infrastructure, the cybersecurity policy was actually saying maintenance and promotion of the safety principles. And so the fact that we have to look at this safety, especially for critical infrastructure, completely makes sense to me. And so the challenge is, how do we make sure we can actually get the information we need to do the effective analysis? And so things that are sort of behind, when you actually go and look at the safety standards that are out there, they're asking for things like unique IDs, dependencies between components, build configuration, knowing existing bugs and workarounds, and then documentation requirements. I worked with Pete Brink from UL, and he had access to all of the safety standards. I only had access to the ones that were freely available, but between the two of us, we were able to sort of summarize all the things that we kind of need to look at having in play. And funnily enough, when you actually look at it, the first part of it kind of looks like an SBOM. So the challenge becomes then, okay, how can we sort of extend it a little bit further so that we can catch the information we're going to need for the safety analysis? And also, an important principle is, requirements are what's going to tell you if you're done or not. And when we have the speed of open source change, and we have vulnerabilities coming in, we have remediations coming in, we want to fix them, we want to get them out faster, how do you know you're still adhering to those safety principles? So it's going to be really key that we have the ability to make automation and to have this all automated so that we can actually have effectively a knowledge web that describes your system, and you can know exactly what you need to retest, and then work it from there. So SBOMs today are machine readable. We've built them that way. And then SPDX's format also has a wide range of use cases beyond the minimum that let you sort of record the sources, vulnerabilities, patches, build calibration data, and so forth. And that is where I think we have a path to automation of all this. So just common understanding of what SBOM is today. This is the definition of NTIA. It's a formal record of supply chain components and relationships used in software. And they could be open, proprietary, libraries, free, whatever. Anything and it could be, quite frankly, files and data and models and AI. We've got a lot of stuff that's out there, and we're all, it's contributing to making effective programs. However, we also need to make sure we can keep them secure. So NTIA's guidance for this one, for the minimum, was a very restricted set of fields and then some practices that they wanted to see on there. SPDX was one of the formats that was recognized from the start on it. And the minimum elements for it, again, the restricted set is supplier name, component name, version of component, any other unique identifier, dependency relationship, author of the SBOM data, and timestamp when the SBOM data was created. SPDX 2.2, which is an ISO standard, is able to support the minimum today right out the box. In fact, we've actually had it there, and it's been available for a couple of years now. So there are things there. We've also have checkers to make sure that you have conformance to the NTI minimums. And so right now we're in a bit of a wild west for the SBOM data and what's going into the SBOMs, in the sense that every tool is sort of doing things slightly differently, and we're trying to come up with some norms for practice. And so having these checkers available to say, yes, you're doing something that's coherent and conformant with at least the minimum is a good starting point. But it brings the question up of when should an SBOM be created or consumed? And realistically, the safety and security is expecting the configuration management information to be maintained throughout the software lifecycle. And so literally the information is accurate and known at various points. And so these SBOMs create a mechanism for tracking and keeping this information current going forward. But as you can sort of see, there's a lot of information that happens at different points in time, like configurations will happening when you're deploying, or calibrations for that matter. And then, you might find risks and vulnerabilities as you're in production. You might find, oh, hey, I've got to replace something in the field, so I need to, retire and plan for the next generation. All of these are places where information is known, and it's known accurately at that point in time, but at another point in life cycle, you might be guessing. So having it so we can focus and pull this information with tooling appropriate to this phase in the life cycle is going to be an important factor here. And this is one of the reasons that in the CISA efforts, we spent the last 6 months with a group of industry stakeholders trying to define what are the types of SBOMs we're actually sort of working with. And they roughly map to the life cycles. However, we've got the concept, sometimes you can't take it in the life cycle, so you have to do something analyzed with third-party tools and heuristics. But the first step is obviously the design, and then when you're planning to do something, what information do you have? Source, you're bringing things in to your organization, you're trying to understand what you want to use, you want to scan it, make sure there's no surprises, have it ask for SBOMs from when you're doing procurement, but understand what you're trying to pull together. Then, as you actually pull it together, you want to know exactly what you've pulled in. The safety standards are going to need this. And so you're going to want to link back to the source and be coherent in your information. And then once you've actually released your product, you've got to build SBOM for it, you're giving it to someone else who's going to deploy it with the configuration. They should be able to refer back to the build SBOM that they got, but also add in the configuration information that they need to record. So as you can sort of see, this information is available at different times in the ecosystem. And so being able to catch it where it's crisp and fresh and accurate is going to be key for us to really get a lot of automation in play. So one of the things you can sort of do is do a rough mapping of, you generate the SBOMs where the data is available. And so things like a source SBOM is roughly going to be happening during your procure and development stage. A build SBOM, you're building, you're testing, releasing. There's artifacts and information there that you have immediately as part of the build flow, like obviously from the CI/CD perspective. As you're compiling, you know exactly what you're putting together in that image, so capture it. And then when you've deployed it, you know exactly how you've configured it and put it out on your system. So record that and make sure you record exactly which image you actually deployed at a point in time. And then if you're wanting to look over a range of time, have things changed out from underneath you in your dynamic libraries, things like that, you might want to work with a runtime SBOM. And it's time to retire this component. I need to go plan and figure out how I'm going to replace this functionality or improve this functionality. So the basic software lifecycle does have the right points of time in it. It's just going to be a matter of figuring out how we get tooling to pull the information effectively and then be able to share it and refer. So modularity is going to be pretty key to us on this. And
so, Kate, if I may ask a question here, if you go back to the previous slide, if you don't mind, that's kind of like a little bit, some engineers are thinking as confusing. We're not saying that we're going to create a distinct SBOM file, right? It has to be connected. Let's say we designed SBOM, now we create SBOM, or in the source phases, we create another SBOM. Means end of the day should be kind of integrated, means like we're not creating one SBOM and saying done, but we're going to really carry out those SBOM files or the content throughout the lifecycle. That's what you meant, isn't it?
Yeah, we're carrying the content available, and we're having relationships that connect one SBOM to another SBOM, be it in a database, be it documents, etc. So being able to connect and say, this file here this .o is created from this C file, and these 5 .o files are what made it into your library, and have that traceability is possible today. Okay, and keeping it modular so that you have sort of like an SBOM per useful component, rather than trying to put everything all in one. You can do it all in one in a database, but file by file, you may not want to.
Yeah, good point. Thank you.
Sure, thanks. Good question. So to that point, when you actually use something like a runtime SBOM, what you're looking at here is, okay, what's been ran in the system? Well, that may point to a bunch of deployed SBOMs, okay? They won't all be included in it, but they may be pointing to them. And those deployed SBOMs may point to build SBOMs, which may point in other terms to other build SBOMs. And so that, this way you build up a system. And everything, the modularity of recording things at logical places where the information's there and accurate. You may have built something here 5 weeks before you built something here, and and then combine them with integration. The timescales don't always be there, but being able to refer between this gives us some useful visibility and about what's there and how a system's been composed. So you effectively have a mesh network, you've got a knowledge mesh that can be created over time for your system. And when we go to safety critical, we have to go back to the sources too. That's pretty much what the standards are expecting that I've been looking at and so forth. So being able to be efficient about linking back from the build to the sources is actually possible. If anyone's familiar with the Zephyr project, there's a one-line command there you can add on, and you'll suddenly, every time you do a build, you'll get one build SBOM and 2 source SBOMs, and they're all linked. So you can see exactly what made it into your final image, and your ELF image that goes onto gets downloaded onto some sort of sensor system. So it's possible today. We have proof of concepts out there. And it's just a matter of saying, yeah, we need to figure out how we can get this systematized a bit more. So what's going to happen in the field event, ideally, is, customers and integrators are going to need to check the safety profile. So, customer security team recognizes they've got some vulnerability they're going to need to deal with. Ideally, they'll now be able to check the deployed SBOM. What have they put on their system? And they may need to link back to their build or source SBOMs, depending on what's happening. And by linking back to the source SBOMs and knowing exactly if the source says, we're going to eliminate a lot of false positives that are out there. If we just looked at the component level, we have a lot of false positives in the security industry that people waste time. But if you can actually say this file is in or not and be authoritative, that suddenly gives us a way of reducing a lot of drudge work, which helps on the automation. And a lot of the high stress drudge work over Christmas is at that. So getting to the stage where we can have the impact analysis and determine if we need to do a mitigation. First step is, do we even need to do anything? And if we do need to do something, okay, well, might go back to our integrator who provided us something. And they will obviously get the product update and find the fix, apply it, generate a new SBOM, build SBOM. And if there may be an aspect of having to check the safety profile here, and that new build SBOM may go into customer procurement, which then may take it over to the ops team to deploy and their system, and they may need to check the safety profile as well. But their new deploy SBOM would then refer to the new build SBOM. And so in this way, we can keep the information current over time as we update it. And also we have a way of potentially starting to check for those safety profile aspects in an automated fashion. So let me so what SPDX is doing is enabling the linkage between what's happening in the design SBOM to the sources. And, I've designed my system. I'm saying I'm bringing all these pieces in. I may want to point to that. I may want to point to the build tool I plan on using. I may want to be able to say, oh, here's the app I'm doing. Here's the configurations I'm going to use. The build SBOM may be wanting to point back to the sources. These are the ones I actually pulled from. Here's the hashes on each of the source files. I know it has changed or has not changed. And hey, I've deployed it. Okay, this is the build I've used. And then as I'm testing it and running it, there's logs and evidence that are coming out that might be able to be very useful to satisfying the requirements in the safety profile. So by linking these things in a modular and then having the relationships between them be explicit, we start to be able to mine this information for getting the safety analysis done. So to give you a quick overview of what's happening in SPDX, the current version out there in the field and in production right now is 2.3. We started this off with the view of communicating this component and metadata information with software, and it had an initial model. We've been changing it up. The 2.2 version we actually took through ISO formally, and we actually were rather proud of the fact that we were able to get it available for free. So it's one of the ISO standards that's not behind a paywall. And since I've been blocked by a bunch of the safety standards being behind a paywall, this was important to me and to some of the others as well. But anyone who wants to see it, you can go up there and get it. And the difference between 2.2 and 2.3 is there's a few more fields added. But all the same information is there, and 2.2 is sufficient for satisfying minimum requirements, and then a lot more too. We also maintain a web version of the spec as it evolves, and so you can go in and look and participate. Since we're an open source project, effectively that's doing the standard, we're pretty good about trying to give credit for anyone who's participated with us over time. And we're working very focused on, continuously improving it, because we started off with some use cases that were just sort of package related, and then we had to add structures and packages of packages and packages of packages, which became things like, oh, hey, containers, or distros, or things like that. So we've had ways of representing arbitrary hierarchies pretty much since the transition over to 2.2, release 2. We've added support for snippets, because bugs, be them licensing, be they security bugs, are found in a couple lines of code sometimes that have been copied around the internet, and sometimes we needed to record that. We moved our spec from being a written doc over to GitHub, and it's all there right now on our GitHub repo. And then around the same time, the NTIA efforts were forming, the Japanese team that is working mostly open chain wanted to have a light version of this. And it's we got pretty close between the two things from different points of view, between what SPDX Lite was and what the NTIA minimum was. I think there's one or two fields slightly different that they chose, but they wanted a way that people could manually enter this in the lower tiers of their supply chain. And so you can approach this at different levels and different things. Anyhow, and then we took it to ISO, we made it, and then we got through ISO, and right now we published 2.3 last year to improve interoperability with CycloneDX and a few other formats, so that we can round trip between these formats a bit better. And then this year, we're releasing our, in fact, we just did last weekend, we put out our release candidate for 3.0, and there's prototyping in progress, and we certainly welcome people to come in and participate with us on it and help us improve it before we lock it in. The key thing to understand with SPDX is there's a formal model underneath it, and there has been since the 2.0 timeframe, that lets us interchange between different actual file formats. So you can think of SPDX in some ways like a language, probably more than a format. But it lets us go from things like JSON and YAML and XML to things like spreadsheets. And we have parts of our community that want to see things in spreadsheets, and we still need to share them that way. So the fact that we can express it losslessly in all these formats is a function of the fact that we do have an underlying model, and we've persisted and kept with that. The other thing is that I was mentioning how you can connect things. Well, you connect things by relationships. And being able to be explicit about whether something is statically or dynamically linking is very powerful in terms of knowing where there may be issues. And when we start talking about things like specifications and requirements, having a relation to say, this is a specification for, this is a requirement for more, all of that tends to be useful as well. So you can, as you can see, there's fairly rich set of relationships. We're reworking this a bit. I guess basically parameterizing a lot of this, actually. You'll see some redundancy here between the types of dependencies. We're sort of be parameterizing it a little bit and adding more securities to related ones in the 3.0 release. So you'll be seeing a lot of change in this table going forward, but this gives you a flavor for the types of things you can do with it right now, today. We have a fair number of generation tools. We've got, libraries out there to help you work with the SPDX spec for producing and consuming it that the community has put together, and help is very much welcome on moving these forward. We've been prototyping the 3.0 spec right now in the Python libraries, so the tool's Python. If you want to see what's happening on 3.0, there's a version there. But there's a Golang version, there's a Java version. We'd love to get a Rust version going and some other ones. And then we also have some R-blank tools that are validators. So it started off as a pretty printer. It then turned into a validator, and then it turned into a translation tool. So we use this as a part of the foundation for the conformance checker as well. We integrate the conformance checker to these tools. So there's one site that the project supports that people can go and put a file in and say, is it valid or not? So we want to make these sorts of things easy and approachable for people. There's also, those tools are obviously, in order to produce, they also consume. And we also have a open source vulnerability lookup tool out there where you're bringing in create a JSON file that connects up the SPDX to the vulnerabilities you can find with it. And then there's also the conformance checker I was mentioning. So these are the tools that the project is supporting from our community. However, there's a lot more tools out there that are working with SPDX and commercial as well as open source. And so we're hoping to make that more visible in the next few months. But, there's things there. Now, there's also been a lot of work going on about SBOMs. As people know, the actual Python library work I was just referring to was actually funded by OpenSSF to help us move it forward. It had gotten bit rotted. And so we cleaned it up, restructured it, and basically refactored it so you can go from 2.3 to 3.0 and be able to work with both of those releases, 2.2, 2.3, and 3.0 actually. And that'll help with the migration. And then the NTIA efforts transferred to CISA. And there's 4 working groups on sharing, adoption, cloud, and tooling. I've been working with the tooling one, and part of trying to get this definition of the types is people kept talking past each other about the types of SBOMs they were using. And there's coordination going on with the international side too. So I was mentioning at the start, we've put out a release candidate for SPDX. Why? Well, wanted to have additional use cases, specifically the AI and the data use cases were not being effectively able to be transparent enough in terms of how were models created, what is a lineage of data sets, how do we actually connect this up, and then the security and defects information. We always had the ability to reference out to things, but people wanted to contain it within the SBOMs, and so we've talked to various people and figured out, okay, what's consensus, and we've been trying to include it. We're trying to simplify things so that if you don't care about licensing, you don't need to care about it. You just look at the security profile in. If you don't care about security, you only care about licensing, same story. We have constituents in different areas, and all of these things are elements of risk at the end of the day. So. Making it possible.
Yeah, Kate, I may actually questions on the tooling aspect of it. I know we are working with SPDX 3. When we look at the version SPDX 2, now looking for 3, one of the question I have been asking many times, and developer says, do I have to create it because it looks like another language that I have to learn? And another one is like, I have so much legacy code has been written for a while. Where can I start? This tool is going to help me out to start for legacy systems or the code that I have built for years. Do you have any kind of suggestions or recommendations on how to start SBOM for existing code base? Second is like, how would you suggest for developers? Because DevSecOps is kind of more about, there's so many developers like to write the code as IAC concept, like to code everything. Do you have any thoughts on it? Or advice?
Well, the actual minimum you need to start with is pretty small, and it's pretty approachable. So the reason we're doing these libraries and focusing on the libraries is once you hook your libraries into your build flow, You can choose which version you want to generate and if you want to pick up new capabilities or not. And so the libraries will help us abstract some of the details as well as help improve the consistency. So I would encourage people to start looking at the Python library in particular if you're interested in 3.0. There are a variety of tools out there, from scanning tools, commercial and open source, that should be able to work with your existing code bases and summarize them for you. And for your build flows, putting it into a build flow and into a make system is a matter of calling the libraries, or at least generating some of the information. And if you're using Yocto today, which is a embedded system for building systems and distros, it's a one-line change now. If you wanted to suddenly start generating out all the SBOMs, and by putting these things in the build flow,
that is amazing.
Yeah, well,
that's amazing. With the one-line code change is amazing. That's what the developer like to have, a one-line code and change everything. Great.
So we need to be in the build. We need to be in the build flows. Is what has to happen. So if people can help us get into the build flows, then the developers' jobs become so much easier. Anyhow, thank you for the question, and we're trying to simplify things so that you can only focus on what you really care about, and make it flexible, so you can communicate about a single element and the relationship structures. The 3.0 model, again, is a formal model underneath it. It's a little bit different than what I've got on this diagram yet. We're still, like I say, we just released a candidate. We'll have the diagrams updated shortly. But the important thing to understand is we have a core model, then we have a software profile. And we broke them apart right now because we're going to be having a hardware profile. And we also have a data profile, which we may promote up. We're debating it. Okay, but at the heart of it, data is just files and groups of files, which is what software is. And so the profiles we're supporting are going to be the licensing profile, security, build, AI, dataset, and usage. Usage is coming about from the needs for people to say, hey, I can use this in development, but I can't take it to production. And in certain systems like the automotive industry and so forth, that is a key consideration you want to communicate as you're sharing information and sharing code. So we also are able to, we've also adjusted SPDX so you can do extensions. So if you've got proprietary information that you want to be capturing with it, there's a way you can extend it for your own internal use within a format. We added that in, and then the software profile is things like, the snippet file and package that we've always had. And then we had an SBOM concept that creates a SBOM as a way of summarizing things. And we also have dependency relationships, which I was talking a little bit about earlier. So the infrastructure is in Markdown. It's all up on GitHub. And we have various classes, properties, and enumerations. And we'll be able to generate the schemas automatically in these different formats. So it's there today. You can go look at it. It's not as well documented as we would like, but by the time we get to the formal release, it will be. However, for developers who like to go into the bleeding edge, we certainly welcome any collaboration they want to do and ask questions. We have a Gitter channel. People can ask there too.
Kate, one more question on the profile. Are there any existing profiles that you can recommend to the people they can start and use it? Because instead of creating for themselves, let's say I'm looking for a security profile or the licensing profile.
Yeah.
And sometimes, let's say I'm using, go ahead.
Yeah, no, so we started introducing the concept of profiles back in the 2.2 and 2.3 with the light profile, which is saying these subset of fields, all the fields are available. The question is what is mandatory and what's not within a profile. And so you can sort of look at these profiles as ways of looking at lenses on these fields and how you make what you want to make sure is populated in a consistent fashion. As people are starting to work with these profiles, I'd say start working with libraries and so forth. The licensing profile in particular has been refreshed. Let me just go into it a little bit.
Okay.
We've gone into it. And so I'd say the licensing profile is probably, we did some consistency and coherency It's there. It's there in the system. The security profile has had the most change recently, and this is definitely where we would welcome people to tell us where we've gotten some things wrong. But I'd say licensing is easy to approach. I think security is where we could use the help the most, making sure that we've tried to line up with what we understand to be industry standards like VEX, like making sure we have different ways of referring to all the different types of security advisories out there, and conveying some of the limited information that people want to convey with the security information. So there's a team that meets every week. Each of these profiles has teams associated with it who've been focusing on honing it down. Security team meets every Wednesday. There's a build profile team, and this is a new profile we've been adding in, such that we can actually catch the pedigree and the build elements that are being used to create a system so that you can reproduce that aspect of it. And so looking at the inputs and outputs, and being able to assess if there's issues. And from the safety perspective, we need to know, how are things built? And being able to record this accurately is part of the analysis we're going to need. If you've got a bug in your tool chain that you've been working on various systems and it populates further forward, that's going to be potentially a lot of mitigation that you're going to need to start looking at, especially like in the library of your tool chain or something like that. You're going to want to make sure you can be very authoritative of where this tool has been used, etc., and be able to mitigate effectively. The other thing that's sort of a new concept that we're bringing in is the concept of an AI bill of materials. And there's an AI profile and a data set profile, because data sets and models effectively create trained models, and it's the trained models that are working in these applications right now. And we didn't have a good way of representing it. So just to sort of look at, data model and code, we could build up, we could create a build SBOM for the model, could create and then referring back to the sources that it was created from. We could create the AI application, which has been generated from, again, some sources, and it depends on a trained model. We could, deploy that model and say it's depending on the trained model and some runtime dependencies on some data. And we could do this with SPDX today. Okay, the 2.3 version of SPDX will replace, look at all these concepts. However, expressing how the model is trained and the different training data and how this all was an ambiguity. We didn't have a good way of saying how. So this was motivating part of the use case changes, like I say. When we find the gaps, that's what motivates us to advance the specification. So we worked with various researchers and did a survey of the various transparency mechanisms out there, data sheets, model cards, and fact sheets, and found that there were some common denominator problems, fields. Anything here in bold is pretty much an SPDX 2.3, and the new profiles were the ones that were being added here, because these are the things that people wanted to catch about AI. And similarly, on the data set side, they wanted to catch some things, some types of information as well with the data set. But most of it was already in SPDX. We just extended it a little bit further so that we could catch these use cases. The other profile I talked about briefly was usage, and they're interested in what's the intended usage, what are the build conditions. So it relates back to that build profile we were talking about as well. And if there's test conditions and what's it valid until and so forth. So this may or may not make it into 3.0. We're still, in discussions with that team. So it may be a very late change in past release, first release candidate, but they've given us some preliminary thoughts and things that they want to see, and so we'll see if we can make it happen. If not now, it'll be in the 3.1. So after 3.0, we'll be adding in a hardware profile. Work started on that, because today most modern hardware is just files. And it's, things that are connected together and, processed through tools, which we know how to represent. There may be a set of serial numbers you may want to associate with this, but, it should be a fairly interesting. So if people are interested in starting to look at a hardware profile, please contact me. And then obviously the safety standards. We've got, I think with the 3.0, we'll have all the key fields we need. However, coming up with the methodologies, showing people how to use things, how to work with the config management systems and so forth is something we're going to continue to flesh out and work through more and more examples. And then if we have to make adjustments, we'll put them into there. To give a bit of a teaser for it, at FOSDEM earlier this year in February, Nicole Papler gave a talk on how she can use the SPDX relationships to represent a safety case. And be able to satisfy V-model type of analysis. So the link is in the slides. Feel free to watch her video. But just to give you the teaser on it, as you have your safety concept, a packet, in your design SBOM, that may be the specification for your requirements, which are requirements for your tests and your sources. You create a test framework. You have executables. Your executable goes into your framework as it's deployed, and it generates out logs and so forth. And that's the evidence that proves you've satisfied your requirement. And so when you actually break it down to a single one, hey, you've got a single requirement that you have code mapped to source code and to make files, which generates those executables. And you also may have tests, again, that are in the framework that have logs that are, again, evidence for the requirement. If we can get to that stage of precision, then suddenly when you're fixing something like a file, you have to remediate in the file, you suddenly have exactly the flow that you need to basically retest, all automated in your system in a way that you can work between tools with and have that evidence. So comparing the evidence, you've satisfied, you're done. And
Kate, on this slide, and can we think about that sourcing SBOM will be a good connection to requirement phases? Like I see a lot of requirement we are developing. Maybe we can start to think about SBOM as we are writing requirements.
Definitely. You definitely should be thinking about, as you're working in requirements, you're trying to figure out what you're putting together. Well, I'd say you do your requirements at different levels and how this connects. But when you've implemented your requirement, you have sources there, and you need to have that traceability and coverage in some of the standards. And so this gives us a way of linking this information together via these types of links that are there.
That's actually a key point, having a traceability for any items that start from inception requirements all the way to the end. That gives the visibility and plus the transparency of any dependencies from beginning to the deployments.
Exactly. And you found a bug out there. Okay, you may need to change the code, but hey, you have your impact analysis from the production field. They say, I've got a new requirement I wasn't capturing. I need to put this into my requirement set. So you can put your new tests in, and you have the new logs, and again, you've got your evidence to satisfy your requirements, and you have that traceability. So having these name type of relationships and having them between elements, be it at a SBOM level or be it at elements within an SBOM, is I think what's going to be very powerful for us to start to get this automation in play. So we're working on 3.1. We meet every Friday on that one. If people are interested in that, happy to have you, join into the discussions and tell us where, bring in the use cases. Let's see if we can, model it effectively with what we've got today, and if not, what we need to extend. And so Nicole Papler is, she's come in from the TÜV Süd side. She works for Electrometis now as a CTO there, and I'm interested in this area as well. So either of us reach out, and we'll happily pull you into the discussions. So if you got a use case that you want to make sure is supported, feel free to join on our mail lists or add issues into our specs, and try it. Let us know if you see issues. So I guess with that, thank you. And do you have any questions?
Great information. So much information about SPDX. We have to learn a lot, seems, and we have to do that. So the couple kind of recapping what you said so far. I'm looking for the question as well. And what you said so far, and Kate, I took an action is SBOM should be traceable from beginning to end. And what do you think about the traceability and DevSecOps, and how the traceability can be achieved under DevSecOps concept? Do you have any few recommendations on DevSecOps and CI/CD pipeline as an example, and how the traceable can be? Yeah,
so we're talking with people like at Google and so forth. And the Google actually was helping us come up with the build flow. But literally, anytime you are producing an artifact, an image in your DevSecOps flow, there should be an SBOM just coming out on the side as a sidecar with it today. We know it's possible,
right?
But it's a matter of changing the instrumentation and working with the pieces that are in the flow. But just getting to the stage where, okay, you've got it. You've got your executable. You've got the SBOM. They're correlated. They're hashed. You can match them, and having them there. Most of them ones you may or may not need. But if you do need them, you have the way to get to them. So,
another kind of question I have been hearing a lot is, how about for interdependencies? Because sometimes we know what has been shared as the first supply chain order. Let's say I know my libraries, but I don't know how much go deeper into another library, because library may be using another libraries and packaging together and releasing another version. So what is your suggestion? How much we can go deeper and deeper in hierarchy, or do we have to, everybody has to their own first order of supply chain? So what's the strategy on people can follow it?
Strategy is represent what you can, where you can be authoritative as opposed to guessing.
Right.
So represent, if you know exactly which dependencies you're connecting to, fine. When you build up an SBOM through your build, and you have your .a's for the libraries, and then you also have the libraries linked together in different ways, and then creating the final elf image, things like that on the embedded IoT side. You've got all the intermediates there, but if you were sort of given something that you've got from outside, hey, I just know this. I've got that, link to that, say what you know, and let someone go and ask the people who actually know the details behind that lower one and bring that forward. I think it's important not to, when you have to go down to the C source level, hopefully the contracts have been negotiated that you get the access to the SIPs, but just focus on what you can be authoritative about and capture that at this point, and we'll advance things tremendously.
Thank you, Kate. It's actually interesting that you brought up the contracting issues, because sometimes the vendors or the people, they don't want to share their SBOM because of security reasons. I know for a safety sake, we would like to know, but on the other hand, and we're going to make sure that, I guess, we have to protect the SBOM file that we are getting from our vendors or contractors, right? Because it's just sharing a lot of secrets with respect to all the dependencies and all the libraries.
I think we've been working under NDAs for years. Okay, that's a normal part of business practice, is to work under NDAs. And the SBOMs would just be considered an NDA artifact that goes along with the binary. The same way that you have in your contract,
right? You
don't reverse engineer your binary. Well, you don't share the SBOM if we're giving it to you. But at least you have the access if you need it. And then you're also having, some of these things have really long life cycles too, especially in the critical infrastructure. And there's no guarantee a company will be around in 10 years' time or 15 years' time. And you may need to remediate something in the field at that point in time. So we need to be able to handle and plan for these type of long life cycles as well. And the SBOMs will give us a bit more transparency and a good path for the reproducibility when we need to retest back to those requirements.
Great. That goes back to traceabilities. And other things you brought up today about the safety, and people are not really thinking a lot SBOM and safety related together. Like safety is, it's important. Maybe can reiterate one more time, and as the safety and SBOM relationship.
Well, anything that's critical infrastructure has safety considerations with it. When you do the cybersecurity remediation for it, you have to think about, am I going to make the situation worse or not? Because when we are in critical infrastructure, we can potentially, it could harm people, or, significant catastrophic losses. So I would encourage people to look at the NIST presentation. I've got the link here. And the Japanese were kind enough to actually put an English translation out there and read about the fact that, we have to consider the safety profiles when we're doing cybersecurity for critical infrastructure. And so, as you can see, having to do this type of thing at scale, we're going to have to automate it, which means it has to be machine readable, and we can use the tools available to help our tasks.
That's great. And I have one more last question about the hardware pieces. And you said interesting word about the hardware is becoming more about the software. And there is a concept of HBOM, hardware bill of materials. I guess we're not replacing hardware bill of materials, right? We are looking for more about the embedded software's component spec. Can you a little bit talk about the hardware bill of materials and SBOM?
Safety is systems, okay? And systems of hardware and software working together. So we are going to have to capture some of the hardware information that's relevant. You know, we've seen Heartbleed type of vulnerabilities where the pipeline of the processors were contributing to the vulnerabilities, and we had to work around that type of thing. So being able to capture sometimes that type of information in very high assurance cases, we're going to need. And so we need a way of capturing that. Now, building chips and boards today is a set of files, and being able to record that type of file when it's appropriate. There's a lot of open hardware work going on, be it in, you can get access to this type of information, like from ARM, from RISC-V, from PowerPC, and so forth. You can get access to the core for the code and the pipelines. You can get access to information for the Baum and Gerber files for the boards, and summarizing this and understanding the relationship for this between the software that gets loaded onto it and then how this whole system works is needed in some cases. And we should be able to connect this all together in a system, again, for satisfying these requirements. However, let's move. We're starting with the software and the low-level software. Embedded we can do today. Embedded firmware we can do today. It's just software. But getting it down to below the, like I say, FPGA level and below, we're seeing a lot of work and innovation happening there, and we should be able to capture it.
That goes back to all about the traceability and safety and all connection. It doesn't matter where you do hardware and software, it has to be traceable, every component.
Yeah. Yep.
Okay, thank you so much for the great information on SBOM and other things. I know a lot of questions still I have, but we don't have enough time to answer those questions, but it was really, really helpful to enlighten the community, especially DevSecOps. I'm kind of thinking DevSecOps is more about enabler for SBOM generation and creation and lifetime perspective. Thank you for participation, Kate. I'm looking forward to have another session with you sometimes, another DevSecOps Days event. Thank you.